statement of next question is use Cayley-Hamilton theorem. Use Cayley-Hamilton theorem. Use Cayley-Hamilton theorem to find the inverse of a matrix A which is equal to, so this is first row 1 2 3 0 1 2 0 0 1. So just understand the method, then you will solve any type of question. Now from this, the first part is characteristic equation. So what is the characteristic equation? So characteristic equation, the statement of characteristic equation, A minus lambda I determinant is equal to 0. So from this what we get? A minus lambda I. So what is this? This is a matrix which is of this kind: 1 minus lambda 2 3 0 1 minus lambda 2 0 0 1 minus lambda. So this is a minus lambda I matrix. Now determinant of A minus lambda I is equal to 0. So it implies this is 1 minus lambda raised to power 3 is equal to 0. So which is a characteristic equation. So this is a characteristic equation. So characteristic equation, if I write this as, so this is a I minus lambda raised to power 3. So characteristic equation, if I write f of lambda, so which is equal to 1 minus lambda raised to power 3, so equal to 0. So which is a characteristic equation. Now simplify it. This is f lambda which is equal to, so this is equal to lambda cube minus 3 lambda into lambda minus 1 plus minus 1, which is equal to 0. So this will become a lambda cube minus 3 lambda square plus 3 lambda minus plus and minus 1 equal to 0. So which is a characteristic equation of our question. Now lambda is the 1 equal to its root 1 minus 3 plus 1 minus 1. So this is a characteristic equation. The statement of Cayley-Hamilton theorem: every square matrices satisfy its characteristic equation. So it implies, by using Cayley-Hamilton theorem, a cube minus 3a square plus 3a minus identity is equal to 0. So this can be written as I which is equal to a cube minus 3a square plus 3a. So if we pre-multiply by the term a inverse, so we get a inverse which is equal to a square minus 3a plus 3i, identity matrix. So in this way we can find the value of a inverse. Suppose this is equation number 1. Now in order to find the value of a inverse, I need to find out a square, 3a and 3i. So first a square, which is a into a. So this is a matrices 1, 2, 3, 0, 1, 2, 0, 0, 1, same 1, 2, 3, 0, 1, 2, 0, 0, 1, this value. Now multiply this matrices, so this will become, so this is of this kind. So when we multiply first this column with this, so it will be 1. When I use second, so it will be 2 plus 2, 2 plus 2. When I use this, this will be 3 plus 4 plus 3. So 3 plus 4 plus 3. Now this, so this will become a 0. And then this, when we multiply by this, so this will become a 1. When we multiply this, so it will be 2 plus 2. Now third row, so this is again 0 and then again it is 0. So last is 1. So this is a matrix of this kind, which is 1, 4, 6 plus 4, 10, here 0, 1, 4 and next is 0, 0, 1. So this is a value of a square. Now first term a square and second term is minus 3a and last term is 3 identity matrices. So this will become the first matrix. So this matrix is 1, 4, 1, 4, 10 and next is 0, 1, 4, next is 0, 0, 1 and next is minus 3 and the matrix is A, 1, 2, 3, 0, 1, 2 and 0, 0, 1. So this is a value of A. And next is plus 3 into identity matrices 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a identity matrices. Now simplify this matrices. So this will become 1 minus 3 plus 3. So this values, and next term is 4 minus 6 and next is 10 minus 9, this term. Now after that the next is 0 minus 0 and next 0 plus 0, after 1 minus 3 and plus 3 and next is 4 minus 6 plus 0 and last is 0 minus 0 plus 0. Next is 0 minus 0 plus 0 and next is 1 minus 3 plus 3. So this value will become, so this is equal to matrix. So this will become a 1 and this will become a minus 2. This will become a again 1. Here it is 0, here it is 1 and here it is minus 2. Here it is 0, next is 0 and next is 1. So this is a square minus 3a plus 3i. So what is this value? So it is a inverse. So in this way, by using Cayley-Hamilton theorem, we can find the value of A inverse, which is equal to 1 minus 2 and 1, 0, 1 minus 2, 0, 0 and 1. Now I want to check whether my question is right or wrong. In order to check my question, I just multiply A into A inverse. So if A is, in this case, 1, 2, 3, 0, 1, 2, 0, 0, 1. And what is this A inverse 1 minus 2, 1, 0, 1 minus 2 and 0, 0, 1. Now multiply these two matrices and check whether it will become identity or not. So if we multiply, so first term will become 1 and next will become minus 2 plus 2, 0 and next will become 1 minus 4 plus 3 again 0. So this values, and similarly this is 0, similarly this is 0 and minus 2 plus 1 and this will be 1 and next is 0, so again 0, 0, 1. So what is this? It is an identity matrix. So it satisfies this condition, A into A inverse into A, which is equal to identity. It means our question is right. So the value of A inverse is right. So there is no problem in any calculation. So in this way we can check that the value of the A inverse. Now next is very important concept, which is minimal polynomial. So minimal polynomial, right? So just understand in a very simple way what is minimal polynomials. Now suppose we have some polynomial of root 1, 2 and 3. Suppose. Then its minimal polynomial is x minus 1, x minus 2, x minus 3. So that is the minimum polynomial, that is the which has the root 1, 2, 3, right? Now again I have 1, 1 and 2. So from these three roots I can construct a polynomial x minus 1 whole square into x minus 2. But this is not a minimal polynomial. This is not a minimal polynomial. Why? This equation has root 1, 1 and 2, but it is not minimal polynomial. So minimal polynomial is x minus 1 and x minus 2. Now this equation satisfies this root and this root. So this is the minimum polynomial which satisfies these three roots. Similarly, if I take the root 1, 1, 1. So basically the equation is x minus 1 raised to power 3. Now its minimal polynomial is not this polynomial. It is a x minus 1. Why? Because this x minus 1 only satisfies this root and this root. So this is a minimal polynomial of. Now it means these are the basic idea to understand the minimal polynomial. So minimal polynomial is the root with the minimum polynomial which has the same root of that equation. So we will understand this with the help of question. Now the statement is find the minimal polynomial of matrix. So statement is, this is very important, find the minimal polynomial of matrix A, which is equal to this values, which is equal to 1 minus 2 minus 3, sorry, 1, this is a 3, here 3, 0, 5, minus 3, 0, 0 and minus 2, 0, 0 and minus 2. So this is a 3. So just I correct this in order to avoid any kind of confusion. So basically it is a number 3. Solution. So how we can find the minimal polynomial? So just remember, first find characteristic equation, then find the minimal polynomial from that characteristic equation, right? Now if roots are different, suppose if we have distinct root of characteristic equation, in that case the minimal polynomial is same as the characteristic equation if roots are distinct, right? Now this is a matrix. So what is characteristic equation? So statement of characteristic equation which is equal to A minus lambda I determinant, and this is equal to 0. So this is a, what is A minus lambda I? A minus lambda I. So this value is equal to 1 minus lambda minus 2, 3, 0, 5 minus lambda minus 3, 0, 0 minus 2 minus lambda. This is A minus lambda. Now simplify this equation. So determinant of A minus lambda I equal to 0 is the characteristic equation. So what is the determinant of A minus lambda I? If we expand this equation with the help of row 1, just C1, so it will be 1 minus lambda into 5 minus lambda into minus 2 minus lambda. So this is a characteristic equation. Now this equation, when it will become equal to 0, so it will has root 1 minus 2 and 5. 1 minus 2 and 5. It means roots are distinct. So minimal polynomial will be itself. So what is its minimal polynomial? So first simplify this equation. So if f of lambda, so this will be, this equation will be lambda, if we simplify this product, so this value will become lambda cube minus 4 lambda square minus 7 lambda minus 7 lambda plus 10. So this is same equation. So this equation and this equation is same. Now this is a characteristic equation and it has distinct roots. So if characteristic root are distinct, then minimal polynomial is itself. Now since characteristic roots of matrix A are 1, -2, 5, then it implies all are distinct. If all are distinct, then minimal polynomial of matrix A is lambda cube minus 4 lambda square minus 7 lambda plus 10. So this is a minimal polynomial. Why? Because roots are distinct. So this is a minimal polynomial of the given equation. Now, if roots are not distinct, they are repeated, in that case the minimal polynomial will be of another type. So just we go to the example. If A is statement, this is very important question. If A is equal to, so if A is equal to matrices 5 minus 6 minus 6 minus 1 4 2 3 minus 6 minus 4. So this matrix find minimal polynomial of A, number 1. So this is my first part. And find A inverse by using minimal polynomial of A. So this is very important type. So just remember, it is expected for examination. So this is very, very important type and expected for examination. Expected for examination. Right. Now, here we have two cases. So this question is also asked in GNDU 2006. So this is also already. Now from this, if we satisfy this, from this, first my aim is to find the characteristic equation. Now solution. So I go to directly. So what is characteristic equation? A minus lambda I determinant, which is equal to 0. So what is this? I just write it is a characteristic equation. But you write all the things. Let A be a matrix, the characteristic equation is A minus lambda I determinant equal to 0. Now from this, it implies this values. So what is A minus lambda I matrices and what is its determinant? So its determinant is written in this form: 5 minus lambda here, 4 minus lambda here, and minus 4 minus lambda here, and here minus 6 minus 1 3, and here 2, here minus 6. So this is our A minus lambda I. Now simplify this determinant. So in order to simplify this determinant, so we get this is equal to first term 5 minus lambda, which is equal to this values bracket 4 minus lambda into minus time this and plus 12. This is this into this minus this. So this will become 12. First I take positive term, then this will become minus lambda, and also I can, this is lambda, so plus lambda square minus 16. So this values lambda square minus 16. So next is plus 6 bracket. So multiply by this, so which is lambda plus 4 and minus 6. So this is, next is minus 6, which is 6 minus 12 plus 3 lambda, this value. So just check calculation. So many time mistake in calculations. Now this value will become 5 minus lambda. So this will become a lambda square minus 4 plus 6, and this is next term is lambda minus 2, this values, and next is minus 6 bracket. So this value is 3 lambda minus 6. So which is 3 lambda minus 6, this term. Now this value is equal to, first I take minus lambda cube, and then which is minus 4 lambda. So first multiply by plus 4 lambda, minus minus plus. Now this is 4 lambda, and this term can be written as, also first I take the lambda cube and lambda square. So first term is minus lambda cube, and then is lambda square, which is 5 lambda square. So this is cube and 5 lambda square. Now next is minus minus plus 4 lambda. This is minus minus 4 lambda plus 20 minus 20, sorry. Here it is minus 20, this values. So we get 4 equation, 2 from this, 2 from this. Now plus 6 lambda. So here 6 lambda minus 12, right, from this. And here minus 18 lambda, and here plus 36. So this will become minus lambda cube plus 5 lambda square, this values, and 10. So this is minus 8 lambda plus, this is negative, plus 4. This value is plus 4. So I get this kind of equation, lambda cube minus 5 lambda square plus 8 lambda minus 4. So this value, this is if we multiply by minus 1. So characteristic equation, so which is a f of lambda, if I write, so this is lambda cube minus 5 lambda square plus 8 lambda minus 4. Now to find its eigenvalue, they find its root. So first I use the hit and trial method. If I substitute 1, so it will be 0. So put lambda equal to 1. So clearly we see that f of 1 equal to 0. It means 1 is the root of this equation. If 1 is the root of this equation, then we find the other two roots. So that will be find out by synthetic method of Horner divisor. 1 minus 5, 8 and minus 4. So here it is a coefficient. So 1 into 1, this is 1. 1 minus 4. So this is a minus 4. This is a 4. This is a 4. So this term is 0. So this is a this is a remainder which is 0, and this is a remaining equation which is lambda square minus 4 lambda plus 4 equal to 0, and this is lambda minus 2 raised to power 2 equal to 0. So this is a repeated root 2 comma 2. Then what is its eigenvalues? So its eigenvalues, lambda equal to 1, 2 and 2. Now here minimal polynomial will be changed because roots are not distinct. So if roots will be distinct, then it will be the same as the characteristic equation. But in this case roots are not distinct. So here the eigenvalues, minimal polynomial will be changed. So what is the root of minimal polynomial? So 1 and 2. So this is a roots of minimal polynomial, A. So this is a root of minimal polynomial A. Then what is the minimal polynomial? So which is P of suppose lambda. So this is a lambda minus 1 into lambda minus 2. So this will become lambda square minus 3 lambda plus 2. So this is a minimal polynomial. Also remember that this polynomial divide the characteristic equation. So also note that P lambda is also divisor of f of lambda, right? So also know that this value divide this values. So here we find the minimal polynomial of A. Now if it is a minimal polynomial of A, then again it satisfy the every matrix satisfy its minimal polynomial. So remember also the square matrix A satisfy its minimal polynomial. It means A square minus 3A plus 2I which is equal to 0. Now in the question it is given that you find A inverse by using minimal polynomial. So remember that as characteristic equation, as the matrices A satisfy characteristic equation, in the same way every square matrix satisfy its minimal polynomial. So remember this result, so that we will use in this root. So every root of minimal polynomial is also root of characteristic equation. So if it satisfy the minimal polynomial, so we get a square minus 3a plus 2i. Now pre-multiply by a inverse. So it will become a minus 3i plus 2a inverse, which is equal to 0. So what we get? We get 2a inverse, which is equal to 3i minus a matrices. So what we get? We get a inverse, which is equal to 1 by 2 into identity matrix minus a matrix, right? Now just find the value of I minus a, then multiply by 1 by 2. So what is I? So I, here it is I, not I, simply 3i. So just 3i. So 3i means, so first we know that 3i means a. So what is 3i? So this is the identity matrix, multiply by 3. So this will be 3 0 0 0 3 0 0 0 and 3 minus a matrix. So what is a matrix? So we know the value of a matrix, which is 5 minus 6 and next is minus 1, 4 and minus 2, and next minus 1, 4 and 2, not negative. So this is a positive. 3 minus 6 and minus 4. 3 minus 6 and minus 4. Now this is 3i minus a matrices. So which is equal to, what is our first term? So only diagonal entry will be changed, the remaining will be same. So first I write remaining term minus 6 minus 6. So this is minus 1 and this is 2 and this is 3 and minus 6. So only diagonal entry will be changed. Why? Because it is. So first is 3 minus 5. 3 minus 5 means minus 2. So this will be positive, plus, plus, minus, plus, minus, plus. Just remember. Now this is 3 minus 4, which is minus 1. This is 3 minus minus 4, yani plus 4, so which is a 7. So this matrix will become minus 2, this is a minus 2 plus 6 plus 6, 1 1 and minus 2, minus 3, 6 and 7. So this is the value of 3i minus a. Now multiply by 1 by 2. So here it is 1 by 2. So this will become, if we multiply by 1 by 2, this will be this values. So what is this? It is a inverse. So this is a inverse, which is equal to this matrices, and here it is a 1 by 2 and here it is minus 2, 6 6 and next is 1 1 and minus 2 1. Next here it will be minus 1, I think, and next is minus 3 and 6 and 7. So here it will be minus 1. So just check the values. Yes, 3 minus 4, here it is minus 1. So this is the value of A inverse. So in this way we can find the A inverse by using minimal polynomial. So remember that the characteristic as A satisfy the characteristic equation in the similar way A satisfy the minimal polynomials. Now these are very important result. So just remember that. So first remember the important result. So first result is that we already discussed. Just remember each root of minimal polynomial of A is also roots of its characteristic equation. Right? So we already seen in the example. So this remember. Second is, if root are distinct, then minimal polynomial is same as the characteristic equation. The distinct, this can be written as distinct roots of characteristic equation distinct roots of characteristic equation of A are also distinct root of its minimal polynomial. Now you will understand these two definition, these two statements. So after doing the question, now this type is very important. Now do some question related to these kind of type. Now in the next lecture we will discuss the new chapter which is called a quadratic form.